Okay, so we're talking ElasticSearch. Some people are probably using it already. Some people probably know more than me. Some of you are just starting. So this is just a basic training. I'm not trying to teach you everything. There's a lot to ElasticSearch, but this hopefully gives you guys a foundation to start off of and learn more. I want you guys to think of ElasticSearch just as a toolbox. It's not like you install ElasticSearch and you're done and search works. You can't just install Symfony or Node and be done making a website. You've got to actually use the tools to make search. ElasticSearch isn't any different. Just a set of tools. You've got to use the tools and do some programming to make those tools work for you. In ElasticSearch, you're creating an index. You put all your documents in the index and then you search against that index. An index is basically a list of terms, and then those terms point to the documents that reference those terms. Just like you go to the back of your book, and if you look up like ElasticSearch in a book index, it's going to say go to page 92 to 93 and page 107. ElasticSearch index is basically the same thing. So the first thing that you need to do is kind of create that index, and then you can start putting documents into it. Like I said in the email, I've kind of created some commands to help me do all of this stuff, to create indexes and to run searches. I'm just using the Symfony console. You don't have to do this. I'm also using the ElasticSearch PHP client. You can do this all through a REST interface. I thought about doing it in Postman or PA or something. But this just ended up being the easiest thing for me to put together. But everything that we're doing here, you can do through the REST API, or you can do in Kibana, or you can do however you want. I'm just doing PHP commands, but there's lots of ways to talk to ElasticSearch. This file is just real simple. It accepts an input that describes what your index should look like. It makes sure that file exists, and then it runs the create command with the client using all that information that you did. The first index that we're going to create, I just have some minor settings in here just to make some of the search relevancy discussion go smoother. Normally, you wouldn't have to pass in any promptings if you just wanted to create an index from scratch. They default to 5 shards. To talk about the search relevancy, I went down to 1 shard. We don't have a ton of documents, and I want to make sure you guys understand how that relevancy scoring works right. So I went down to 1 shard, so the relevancy scoring is just focused on 1 shard. Because term frequency, document frequency is based on shards, and so if everything's on 1 shard, it's easier to do the math and see how it's working. But let's just go ahead and create that index real quick. Again, you can watch, you don't have to follow along. These tools are all there for you if you do want to later or play around with it on your own. But I'm just going to do creating an index using that basic definition that I have. It's creating an index. Fascinating. No, because not every document is going to go to every shard.
That's right.
So some shards will have 2 documents, 1 shard will have another document, and then the term frequencies and document frequencies are different. Okay. So we've created a simple index. What we need to do next is actually put some documents in that index. When you put documents inside of an index, those documents are analyzed and turned from strings into tokens or terms that you can search against. So I have an analyze command so you can kind of see how analyze works. This is just using the analyze endpoint on the REST API. You can pass in something that you want, like Steve's opinion is that red fishes should go swimming on Saturday, whatever. You say what analyzer you want to use. I'm just going to start with the white space analyzer, and you can run that against the analyze endpoint, and you can see what tokens are created. This is the white space analyzer. It just splits on white space. Every time there's a white space, it makes a new token. You can see nothing's changed about it. All the capitalization's kept, and no words are thrown away. Just everything is split by white space, and you get a token. You're getting things like offsets and positions. Those can be used for highlighting, whatnot. When we're doing more search UIs, you can use those to kind of control that. There's different analyzers out there. The one that's the default is called the standard analyzer. And the standard analyzer works basically like the white space analyzer, except it's going to be lowercase and everything. So you can set Saturday's lowercase, and Steve's is now lowercase. Okay. Other than that, it's going to look pretty much just like that white space analyzer. Questions about those? We're going to go through more analyzers later, but those are the ones that you start off with. Okay, so let's go ahead and put these into our index. First thing I want to do is just kind of look at what our index settings are right now. So I'm going to pull down the mappings for the fields inside of our index. And I know there's nothing there, I just want to show you that there's nothing there. So I'm going to get my mappings, and there's no mappings on my index. Mappings basically describe what kind of documents you're putting into Elasticsearch, how Elasticsearch should analyze them, how Elasticsearch understands those fields. Right now we didn't specify any mappings. We didn't turn off dynamic mappings, so when I put documents inside, let me show you my documents. We've got these boring documents. They just have an ID. They've got a field name and some values in there. Just really simple sentences. So if I import those all in, those all get imported in. You can see they're responding with created, whatnot. Those are all in Elasticsearch now. I can look at my mappings again, and you can see it's dynamically analyzed my documents and says, oh, you've got a content field. I'm going to create a text version of that, and then I'm going to create a subfield called keyword, and that's going to use a keyword type. The keyword type, let's look at the keyword analyzer real quick. So I'm going to run this through the keyword analyzer, and you can see you just get one token back. So a keyword is what you put in is what you get out. It doesn't do any splitting. It doesn't do anything weird to it. So by default, most text fields that you give to Elasticsearch are going to have a text type and then a keyword type, and that's what you get if you don't set up anything on your own. Okay, we can kind of look at what those documents look like in Elasticsearch. Let's take document 1 and see what document 1 looks like inside of Elasticsearch. I'm going to use the term vectors endpoint. Again, you can just hit that with REST. I've got a term vectors command. What this does is kind of show you, it can kind of show you how that document looks like inside of Elasticsearch, what terms it ended up being. It's used for some other things, but for now we're just going to use it to look to see what our document looks like. So I'm going to use this term vectors. I'm going to say I want document 1 and I want the content. Oops, I have to spell things right. Document 1, and I want to see what the content field looks like.
Is it just automatically use ID? I didn't know ID that was your
Yeah, good question. So my importing command, I didn't open this up to show you, but I'm indexing on my index with ID from the ID field. So I had to tell it which ID to use. Okay, so looking at document 1, we've got the blue, we've got fish, we've got 1, we've got red, we've got 2. You can see document frequencies, total term frequencies, and term frequencies. So fish appeared in this string 4 times. Throughout the whole shard, it's appeared 6 times, and fish is in 3 of the documents. So that's kind of just showing you what's going on. This will be important for scoring later, okay? But we've got blue, fish, 1, red, 2 for that document. And you could look at the other ones and they would look pretty similar. Nothing crazy, okay? It does. Let's go ahead and try running a search. So the first search I'm going to run is this blue fishes search. I'm doing a query. The type of query I'm doing is a match query. I'm matching on the content field, and I'm looking for the terms blue, fishes. Okay? Let's run that, see how this works, and talk about why it's working the way it does. Okay, so here's the documents I got back. Again, I searched blue fishes. The highest scoring document is red fishes taste the best. Then we get Conan is feeling blue today. 1 fish, 2 fish, red fish, blue fish. 2 fish go swimming in the blue lake. Eden liked tiny blue fish better than the green frogs. So it's returning documents. It feels like, thanks for making us switch to Elasticsearch, Russell. Solar was so much better. What's going on here is you've written a query, and Elasticsearch is doing exactly what you've told it to do, and we probably don't understand how that query is working correctly. We can take a look at the query to better understand how it's being parsed. I'm going to call the validate query endpoint. And what the validate query endpoint does is translates your query from JSON into Lucene. You guys are familiar with Lucene? Basically, it's the search stuff that handles things behind the scene for both Solr and Elasticsearch. But what that's saying is look for in the content blue or look for the content fishes. So it's saying if you have blue or if you have fishes, you match, and go ahead and show us that result. Again, you can confirm that. If I explain this search, I just added an explain true to that endpoint. We can look at why certain documents matched. So you can see here is red fishes taste the best. And if we go into the explanation, it looks super complicated and confusing, but it's super easy to understand once you know what's going on. It's got a score of 1.59. In the weight, it's looking for fishes. That's what matched. Fishes, the score is coming from this IDF, which is inverse document frequency. Here's the formula how they calculate inverse document frequency. You can plug these numbers in and see that you would get this number. This log is actually a natural log, but the inverse document frequency is saying fishes is only in one of these documents. So it's only in document 3. So that's a rare term. Because fishes is a rare term, that probably means if I match on it, that document's going to be a match. Whereas if you're matching on the is going to be in every single document. And so the shouldn't contribute a lot to the score. Fishes only appears in once. It's got to be important. It's going to contribute more to the score.
So that's why fishes shows before any of the blue.
Because
nothing to do with the length of the word.
as not this one. So the inverse document frequency is contributing 1.38. It's a super rare term. That's going to give it tons of weight. But we also have the term frequency normalization. And again, here's your math. If you want to double check your computer's work, here's all the variables. This is also saying this document that you're looking at, content, it had 5 tokens. Most documents have 7.4 tokens. So the fishes appearing in here, it's a shorter string. Fishes is present, and so like if you are looking up, if you have a document that's like frog swim and the F encyclopedia and you search for frog swim is going to be more relevant because it's a shorter content field. The F encyclopedia is going to be super long. It's going to be about frogs, but it's about tons of other things. So frog swim is going to be more relevant. And that term frequency normalization is kind of figuring out that as well. So inside of the document, how common is that term? All of those come out to making this scoring the best. We can keep going through this. You can see Conan matched on blue, and these other ones are matching on blue. And you can, yeah, because it's just matching on blue, because fish and fishes is not matching. So we can go through that and kind of understand what's going on there, looking at those relevancy scorings to see what terms are matching, what terms aren't matching, and going from there. Let's look at how we fix this problem so we actually do kind of what we want. We want it to match blue and we want it to match fish. So looking at blue fishes, and we've just changed, here's the original query, content blue fishes. We've just changed this a little bit. We're still doing a match on content. We're still doing the same query, but now we're saying do an and search instead of an or search. So you've got to have blue and you've got to have fishes. Again, we can look at this in Lucene, and you can see now it's plus content blue plus content fishes. So Lucene, if you don't have a plus inside of it, it's going to be a minus. If you have a plus in front of it, it's a must. You have to have that. And if it has a minus in front of it, you can't have that. So if you're like did Google searches or web crawler searches back in the day, plus, minus, and don't use it all. Okay, we can run that search.
0 matches.
Sorry, what?
In that case, we'd have 0 matches because it requires blue and it requires fishes.
Yeah, so we just executed that search. We've got 0 matches because no document says both fishes and blue. Okay, so even though, well, I probably should have picked a different animal. Even though fishes, we can understand that's the same thing as fish, the computer thinks fishes and fish are 2 separate words. So we've got to teach ElasticSearch that those are actually the same term. And again, there's another analyzer for that. Let's go ahead and look at the analyze blue fishes. We're using the standard analyzer right now. You can see it's just doing blue fishes. But if we use the English analyzer, that will tokenize it to blue and to fish. And it basically, the English analyzer is going to take care of some of your case endings, and it's going to take care of some of your possessive strings so that you can kind of match more documents and hopefully increase your search results.
Is that analyzer smart enough to understand that fishes isn't a word?
No.
Okay.
So let's look back at our original sentence. Steve's opinion is that, I don't even remember what it was. Red fishes should go swimming on Saturday. Let's use the English on that. You can see Saturday, that Y changes to an I. Swimming goes to swim. Steve comes to just no apostrophe. Steve's opinion is gone, so stop words get dropped out. Red fishes should go swim Saturday. So it's not doing English. It's not some super fancy linguistics process. It's just got some basic rules to chop them up and kind of help words match using.
Did they tell you why they changed that to an I?
Because sometimes Y is weird.
That's fine.
I know previously in our stuff we'd have generators like electricity generator and generation. Okay, down to So like iPhone 6 generation would also match generators for that RV or something.
So for the recording, Stephen was talking about how generators and generation both go down to the same stem of gener, and so that can cause problems too. You're widening your recall, but your precision is becoming less accurate. Recall, you're matching more documents. Precision, you're matching the correct documents. So your recall goes up, but your precision goes down. And you'll find with search, it's a battle between precision and recall, and which one do you want better. There's ways to work around this. You can mark certain words as don't stem me. So like if generation is an important word for classifieds, you would protect generation from being stemmed. And that way you could run everything else through stem, or generation would not get collapsed down to gener.
Can you partially do it like generations? We want to stem down to generation, but not down.
Yeah, because generations would, well, you might want to look at using synonyms to do that. But yeah, there's things you can do to figure out and play that correctly. Okay, so now that we've stemmed this correctly, well, we haven't really. We've talked about the English analyzer. We need to redefine our index and our mappings. So previously, we let Elasticsearch kind of figure out what our mappings should look like. Now we want to have more control of it. So this is my index file. I still got my number of shards, but I've added a mappings here. This document, Elasticsearch used to have a concept of types. This is going away in Elasticsearch 7. It's deprecated in Elasticsearch 6. You can just put whatever you want right there. That's the document type. We're changing the properties of that document type mapping. We're doing content. It's still a text, but instead of using the default of standard, we're switching it to English. Okay? So I recreate my index. I repopulate it with all my documents, and then I do my search for blue fishes, and I've got these results. 1 fish, 2 fish, red fish, blue fish. 2 fish go swimming in the blue lake. Eden liked the tiny blue fish better than the green frogs.
When you redo the index, will automatically clear out any?
So what I have my command doing, and I should have talked about this, thank you again, Sagers, is when I'm creating the index, I delete it real quick, and then I create it again and repopulate it. Things that you could do is you could close the index, change it, open it back up. You could make a new index with a different name, populate it, and once that one's done populating, switch a config file to point production to your new index with the new settings or something. But when you're changing the mappings, you've got to not be using it while you're changing those mappings. You can't do it live and have people hitting it. Comments there?
You just can also have an alias
Yeah.
inside Elasticsearch and then create a whole new index and then move what alias wants to instead of changing the production code.
Yeah, that would work as well. I'm not going to go over aliases in this, but you can Google Elasticsearch aliases. Okay, so we've got this matching now. The next thing we can say is, this looks good. Maybe we can say, hey, 2 fish go swimming in the blue lake. Sam, your product owner, comes up to you and says, I did blue fishes, not blue lake and fish, so I don't want that one to search. She's probably not going to say that, but you might get feedback on this that this document is not as relevant as these other ones because it's fish and blue, they're not together.
No, I've said that.
Kenneth will always complain about something, so so we can come to our next search, and again, here's what we were doing before: a match search. This is a match phrase search, and so we're still searching on the content field, but now we want the phrase blue fishes. We can look at that to see what that looks like in Lucene. And you can see it's doing a content quote, bluefish closing quote. That's how that looks like in Lucene. You run that search. And now you've got 1 fish, 2 fish, red fish, blue fish, and Eden liked the tiny blue fish better than the green frogs. We got rid of the 2 fish go swimming in the blue lake. Okay? But now you want that one because it does have blue and fish. It just wasn't as relevant in your opinion. So, since I lived with Kenneth for a long time, here's how that would look. So now we're doing a query. We're doing a Boolean query. A Boolean query is going to let you kind of combine the results of 2 different searches. So we've got one search that's doing a match, blue fishes with an and then we've got another search that's doing our match phrase, just like before, and we're saying, hey, if you match the phrase, you're a much better result than if you don't match the phrase. So I'm going to boost you by 5. I just picked a random number. You can boost whatever you want.
Is that multiplication or is it just...
So it's going to take the final score from the IDF, inverse document frequency and term frequency, and then times it by the boost. So if my IDF TF score was 5, I'm going to times it by 5 and get a 25 score. And I'll show you the explanation if you want to do the math and check the computer. It is a multiplication. There's additive boosts and multiplicative boosts. I'm just showing multiplicative boosts today. So let's do our Bluefish's phrase boost search. And you can see the scores have gone up a lot for these one. 1 fish, 2 fish. Eden liked the tiny blue fish. And then this guy, who didn't match the phrase, has a low score. So all the results are there that we probably would want to have. This is still relevant, just not as relevant. And we're able to use a Boolean search to combine those 2 searches together and tell it, hey, we think the phrase is more important. And that will let you get your relevant search results there. Okay? Let's do one more thing with phrases. We've got a tiny, I didn't even show it. We've got our tiny fish.
You mentioned boosts can get out of control.
Yes, absolutely. S&P was at the search training that I did, and they like boost by thousands and like 5,000s, and their scores are like in the millions. They did crazy things. But anyways, our next one, we've got phrase tiny fish. We know we've got up here, Eden liked the tiny blue fish. We search by that, searching tiny fish phrase, no results. We don't have any results because the phrase is not tiny fish, it's tiny blue fish. Sometimes you want to add a little bit of flexibility in your phrases, and that's when you want to use slop. So we've got tiny fish, we're giving it a slop of 1, and that's saying you can skip 1 word in order to construct this phrase. So we're looking at phrase slop. We're looking at this search now. Because we have a slop of 1, tiny, skip 1 word, fish matches now. And you can do whatever you want. Like you can say Eden fish is the phrase. That's a terrible search, but Eden 1, 2, 3, 4. I didn't count the because that's got stripped out by the English tokenizer.
All right. What if I want to do sort of a fuzzy search with slop? So I want TINI blue or TINI fish to match with that phrase.
Yeah, we're going to do that in our next data set. We'll do some fuzzy searches.
Catering millennials.
Questions about phrase, ands? We did a simple Boolean. We'll do some more Booleans. Any questions so far?
It says Boolean, which means I don't imagine that you
You can.
Limited? Okay.
Yeah,
Boolean
so
is,
the Boolean, you can have a must clause, you can have a should clause, and you can have a must not clause. Boolean is like an and or an or, I guess. Your must is basically your and, your should is your or, and your must not is you can't match
I
this.
can just
And we've got an example of a must
two
not.
weird queries
You
in
can
there.
do whatever you want. It's a toolbox. Do whatever you want with the tools. Question your decisions later.
I heard Boolean and I thought it was 1 or 0. So
Yeah.
yeah.
It is. Okay, I'm gonna switch. I'm done with fish. I'm gonna switch over to our books now, unless there's other questions. Okay, so looking at books. Again, this is just a small, simple data set. We've got title, we've got a summary, we've got a category, we've got a rating, and we've got a release date. We've just got, how many books do we have? We have 5 books, super in-depth document.
I just disagree with the fact that Gandalf was involved in destroying the ring.
That's another discussion. We can talk about that later. If he never came to the Shire, would it have ever been destroyed?
You're right.
Okay. Let's look at the book index just so we can see what that looks like. The book index, again, just number of shards, the math works out. Mappings, we've got a dynamic strict. Remind me to talk about that if I forget to talk about that. We've got our properties. We have a title, text, using an English analyzer, summary, English analyzer, category, keyword. We're doing that as a category, or we're doing that as a keyword because we want to be able to facet on categories later. In order to do facets, you're going to want to use keywords on these terms. We've got a rating as a byte just because it's a small number, and we've got a release date as a date with this format. Nothing fancy. Questions about that mapping? Okay, let's talk about this dynamic strict mapping real quick just so we can see what that looks like. Let me add a new document here real quick. Yeah, title. Okay, let's change this mapping, this dynamic mapping. Oh, it's up here. Right here. Let's change this to true real quick. This is how it was before. Let me create this index. Create, index create books, and let's load it up. All books. And then if we just do a search, well, yeah, we can do a search. Let's just match everything real quick. We've got this title, pizza, favorite ham in there. Doesn't look like any of our other documents. We can look at the term vectors for that. That's document 6. Let's look at the title and the favorite. You can see it's indexed pizza and it's indexed ham. Sometimes you want that, sometimes you don't. If you don't want that, you can set this to either false. Let's recreate this real quick. Let's index that again. That last document you can see is still created, but now if we look at those term vectors, because the strict was set to true, it's going to let you index title, but you can see favorites is gone. And so the document's still going in, but it's only letting you use the fields that you defined here. The last option you like, the last option there is, the one I like, is strict. Let's do that again. Let's create it, index it. Oops, what did I do? That's a good idea. And you can see this last one now had a 400 mapping set to strict. You tried to use favorite, that's not allowed. And if you did a match all, you can see it's not even in there anymore. So if you're worried about bad documents getting in your index and messing you up, you can turn off that dynamic mapping. Yeah, enforce that schema. Okay, so let's get that in there without ham. Let's do a basic search. Nothing fancy here. You've seen a search like this. We're going to just search Gandalf real quick, and you can see we're searching in the title for Gandalf. We're getting back Gandalf defends Gondor, the Silmarillion, Cooking Like Gandalf. But if we look at our books, You can see we might have some other things that would have matched, like Lord of the Rings, Gandalf. Should have matched probably.
We're only searching title.
But we're only searching title. So if we wanted to search both title and summary at the same time, we can do a multi-match. So in a multi-match, you have your query, and then you're saying, hey, these are the fields that I want to search in. So if you run that multi-match, now Lord of the Rings is returning in it. Okay? So we're searching one query across two different fields. You can see the scores are here. Gandalf's original, Silmarillion, and the Lord of the Rings and whatever have pretty similar relevance and score. And then these other ones that have Gandalf in the title are a little bit lower. You could say, hey, if you're matching in the title, that's more important, and so we should rank you up higher because the title is a good indication that if it says Gandalf in the title, it's probably about Gandalf. So here you can just say, I'm boosting the results from the title by 2, timesing that result by 2. And here you can see that take effect, where now Lord of the Rings is ranking the lowest in terms of relevancy. You can discuss whether that's right or not, but for the demonstration, we're saying title's more important, and all these other books now rank higher than Lord of the Rings because of that boost. Okay? Let's switch real quick. Sometimes not everyone spells perfect. So here we're doing another search. Instead of spelling Gandalf correctly, we're spelling Gandalf with an O. We want to see that work. Obviously, there's no results because one of our documents spell it wrong. So what we need to do is now allow for a fuzzy search. So this looks just like our other searches, except we're doing a fuzziness of auto currently. Let's change this to 1 real quick. Fuzzy. With that 1 in there, you're saying we're allowed to change 1 letter in order to match a term. So we just have to change that O to an A, and it matches. If 2 letters were wrong, though, nothing's going to match, and so you'd have to bump that up to 2. And now it matches again. If 3 letters were wrong, you'd have to bump that up to 3. And then it, oops, what did I do wrong?
I think both.
let me change a different letter. Okay, and then that's matching again. You can't go higher than 3. So your fuzziness is only going to go so far in this time. I think you might be able to use a fuzzy and go, a fuzzy query right here and go super crazy. But when you're doing a fuzziness down here, you got 1, 2, 3 or auto. Auto is what they recommend to use. Auto looks at the term length, and if it's like this long, you're not allowed to change any characters. If it's that long, you're allowed to change 1, and if it's anything longer, you can change 2 characters. So that's what auto does. And the max is 3. Yeah.
Yeah, you could have said
I could have. Oh, and you have to do JSON correctly. Okay, that's a fuzzy search. Again, you could do a Boolean to combine your fuzzy searches with your phrase searches with your phrase boosting searches. I don't have that all combined, but that's how a fuzzy search works. Questions there?
It doesn't matter the order in which the characters that are wrong are. They
No.
can be like all throughout the word. It doesn't matter.
Nope, doesn't matter.
except apparently it can't be.
Well, there, it matched that time. There's something I'm not understanding here. Anyone know? Okay, you guys can research that. Yeah, only 2 vowels. There's documentation. I've linked to that in the training outline. There's a fuzzy section where you can read more about it, and maybe it says something there. Okay, next after fuzzy, what are we doing on time? 2:36. Let's look at. We've got. What was the last one we ended up? We last did Gandalf multi. Oops, you have to spell Gandalf right now. We've got cooking like Gandalf, Gandalf descends Gondor, whatever. We've got fantasy, 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 and then we've got this cooking nonfiction book. Maybe we're only interested in the fantasy books, and so we want to get rid of this cooking book. Let's look at Gandalf Fantasy. Here we're doing a Boolean. We're saying you must match Gandalf across the title and the summary, and you must also match, oh, I'm doing a term query. Term query, you use that with keywords. That's basically saying you have to match exactly that keyword. You've also got to match fantasy. Okay, let's run that. And I get that one book. Oh, because I'm annoying. So I want to teach something else here. So I did capitalizations, crazy. It's got to match exactly. There's only one that capitalizes it that way. If we look at the books, everyone capital, oops, that's the wrong one. If we look at the books, everyone's capitalizing fantasy differently. How did we handle that before? We used a analyzer we ran it through the standard analyzer, that lowercase everything.
Put some English on it.
Yeah, we put some English on it. However, keywords can't be analyzed because they're a single token. Analyzers are all about converting strings into multiple tokens. And so instead you have to use a normalizer. There's not a built-in normalizer for this, so you have to make your own normalizer to lowercase. So just in your settings, not in your mappings, but in your settings, in the analysis section is where you can define custom analyzers, custom filters, and your normalizers. Here's where I'm defining all my normalizers. I've named it whatever I want. You can call that Bob. It's a custom normalizer, and it's using this filter to normalize. Lowercase is built in, and so I can then reference that normalizer in my keyword. You can think of it as a simple analyzer, and that will make it so all my keywords for the category are lowercase before they become a token. So let me just run that real quick.
Now, you're lower casing them, but is there a way for you to just say case insensitive?
What do you think case insensitive means?
That I
How do you do that in
uppercase,
JavaScript?
Lowercase, whatever. I mean, sure, I convert it, but what I'm saying is if I make a search on all uppercase fantasy, it's still not going to match because you've just made them lowercase.
Oh, let's look to see what happens. Okay, so we're doing books. Is it books or book? Books normalized. Let's put all our books back in. Let's do our search. And so I'm matching, what did I do wrong? I'm matching fantasy, I'm matching capital fantasy, and I'm matching lowercase fantasy. If you explain that, you can see what's happening is I have defined a normalizer, and the normalizer runs both on indexing and on searching. And so your search term goes through that normalizer as well. And that happens with your analyzers. When you search something, it's going to run through your analyzer, and your search terms are going to be run through the analyzer. You can also specify different analyzers for searching and different analyzers for indexing. So like if you need bigrams when you're analyzing, and then you need to just not have bigrams when you're searching so that you can match the bigrams correctly. You can set your search analyzer to standard, your index analyzer to bigrams, and the fancy stuff happens. Bigrams are, you take the word Russell and the first bigram is RU, the second bigram is SS, etc. So this is now matching all these fantasy books. Great, matched, oh, that explains there, that's why it's all long. So it matched all those fantasy books. You'll notice the scores kind of changed a lot. So the score before for this one was 507. When I'm scoring with this one, it's now 1.55. So the scores changed because when you are searching, we did this as part of our must. And so that is contributing to the score. You can see weight category fantasy is adding 538 blah blah blah. Usually when you're faceting, you're more interested in whether that category is present or not present, and the fact that it's present or not present isn't relevant to the relevancy. You just care whether it's there or not there. And so sometimes you don't want that relevancy to score to change, and so that's when you want to use a filter. So this is the exact same search, query bool must, but instead of doing my term query here, I'm doing it inside of the filters, term category fantasy. And now when I do this, the results are exactly the same, except their scores aren't modified for matching that filter. So you use filters whenever you want to not change the relevancy score. Otherwise, they work exactly the same as a must, should, or must not. Okay?
So filter makes it select or don't select, but
Doesn't change the score. Yep. Let's say we want fantasy books, we want Gandalf matches, but we only want the good Gandalf matches. We only want the good fantasy books. Right now we've got a rating of 10, a rating of 6, and a rating of 7. Maybe we only want books that are rated 8 or higher. Okay? So again, that's just another filter. This time we're using a range query because we're working with numbers. We want to do a greater than 8. You can do a greater than 8, less than or equal to 9 if you really wanted to, or whatever your range is. But that's going to filter out so you only get the good books. So now I've got my Lord of the Rings 10. But again, maybe rating is just to help you know what books are more relevant. Maybe you still want to see all the books, you just want the good books to go to the top. And so a rating should influence the score, but not cause you to rank out. So I've got this concept of a weighted rating, and we can see what we're doing here. We're using a function score query on the outer. Inside of that, we're just doing a normal query with our Gandalf matching, our category filtering. But now we've got all this on the inside. With a function scoring, you can kind of write, you can specify some different values of how that score changes based on what your fields are. So we're saying the rating field is going to be a factor of the search. So you need to look at the field rating and then times it by 2, take the square root of that, and then apply that to the score. You can figure out the math of what is important, but that's basically how this is working. The weighted rating, what did I do ED? And now you can see having a 10 rating is putting this one at the top of the score of 4.2. The 7 rating comes next, and then the 6 rating comes last.
All right, what if I want to do all of that, but only show 7 or above?
Then you would just do a facet right here.
Right there, and that would just be...
Or a filter. Yeah, you would just add another filter to say, hey, only 7 and above. Okay? So you can make the values in your documents contribute to that score. Previously, I've seen a lot of people do this all in PHP, like get all the results and then use PHP to analyze it and resort the array. You can do that all in ElasticSearch using these function scorings. Another thing that Hoops and I have talked about in the past is like the post date of a classified ad. If we want newer classified ads to show up first and older classified ads to be less relevant. Again, you would do that with a function score query. So I've gotten rid of everything else. Now we're just saying match Gandalf. And then we have another function. There's some decay scores that you can pick from. I'm using a Gauss math function thing. If your math majors want to explain it, you can. But we're basically saying, look at the release date from today, go back 15 years. You can't specify this in years. You have to do it in days, minutes, or hours. And once you get back 15 years, that score should be 0.75 important. And so the older you are, the less important you're going to be. So we can see Lord of the Rings, even though it's got a good match, it was from 1954. And Cooking Like Gandalf was from 2017, and so that jumps up. Okay? So that looks just like before. Previously, Cooking Like Gandalf was way at the bottom. Lord of the Rings was kind of second place, but as soon as we add that date on it, it readjusts all those scores based on the date. Function scoring, this decay scoring, can also be done with units of distance. So if you want to say, hey, if you're a plumber within 2 miles of me, you're great, but anything after that, start decaying their score because plumbers further than 2 miles are not relevant to me. You can still show them, but they rank down lower. Okay?
For this one,
No, feel free, Sam.
for this one, because it decays by like 0.75 on its overall score, is there ever a possibility for something like this that is pretty I don't know, concrete, that we want it to be ordered based on posting date? And is there any time where doing it this way could actually, if it's a really highly ranked score otherwise, that you could end up with a really old one?
Yes, absolutely. You could still end up with an older post that's more relevant, ranking higher than like if you're looking for books and you find a book that was posted 10 years ago and a fridge that's called the Gandalf fridge, the book might still rank higher because it's more relevant than the fridge, even though the fridge is newer. So if you want a strict posting by date, then you're just going to do a sort, and as soon as you sort, all of your relevancy score is thrown away. Doesn't matter what you do, sorts ignore relevancy score because you're saying, I'm in charge of the order, you're not anymore. So you have to decide what's more important, having an exact order or trying to surface relevance documents to the users based on their search terms. Okay? Let's see. Go ahead.
Never mind.
Okay. Let's look at some last few examples. Let's do this min should match one. So now we're searching for Gandalf, Frodo, Legolas in the title, the summary, same boost as before. If we didn't have this min should match, real quick, let's just take that out. What is this one called? Min should match. Yeah. Let me make this operator and a comma. Okay, so obviously nothing's saying Gandalf, Frodo, and Legolas, so nothing's matching. And I could say, well, I don't want just a strict match anything, because Cooking Like Gandalf doesn't have Frodo or Legolas in it, so I don't want to see that. You could say, hey, I just want to match 2 of those terms. 2 of those terms have to be present. And so saying 2 of those terms have to be present, Lord of the Rings comes back because it says Frodo and Gandalf, and that's the only one that says both. You can express this number either as a hard-coded number, or you can do it as a percentage. Oops. If you do it as percentage, you have to quote it. There it is again. You can see that behind the scenes, it's converted that to a 2. So even though you said 75%, it says, I know what that means, and Lucene doesn't know how to look for percent, so I'm going to change that to a 2. But that lets you be a little bit more flexible, because now that's a 4, because that's 75% of how many I typed. Okay. I'm going to switch to this Shadowfax one. This is the same idea. Gandalf, Frodo, Shadowfax. Look in the title of this summary. 2 of your terms should match. We know we have, well, I don't know, maybe you guys don't memorize them. We have Lord of the Rings has Gandalf and Frodo, and then Gandalf Defends Gondor has Gandalf in the title and Shadowfax in the summary. Let's look how that works. Nothing. Oh, that's because I'm doing the validate queries. We only get Lord of the Rings. This document's not being matched because it only has 1 term in title and it only has 1 term in summary. But what if we do want that to match? We can come to this Shadowfax and change what kind of multi-match that we're doing. Before, we've been doing a best fields multi-match. That's kind of the default. You can look up the documentation, see what all the different options are. But cross fields is interesting. What cross fields does is it takes title and it takes summary and it makes a temporary field and sticks both of the values in there. So title and summary are now catenated together, and when you run that, it's looking at that concatenated field and it sees Gandalf in it and it sees Shadowfax in it, and now that satisfies the minimum requirements. So there's lots of weird things you can do with multi-fields. There's lots of different types. There's best fields, there's most fields, whatever. You can look at the documentation, but if you're trying to do a minimum should match, sometimes you're going to need to do a cross field to allow those terms to appear in different fields but still count as matching.
Is there a performance hit when you do that? Because that has to happen on the fly, right?
I haven't checked. Probably. I don't know. I'd have to do more research on that. Anyone know besides me?
All I know is ElasticSearch is really fast no matter what I ever did.
There you go.
Millions and millions.
Mess it up and blame Spencer when it breaks.
Never had a slow ElasticSearch query.
I imagine that if each of your fields was a 1,000-page novel, and you can concatenate them together, it would probably be a performance hit.
Yeah, I'm sure you can do bad things. Let's look at, let's see. Let's do,
Otherwise, it's-
I think these are the last ones I have. Where is it? Oh, a must, should, and a must not.
Yeah, because it's based on the scene which also runs solar. Solar, I think we ran into a point where we were like doing an or like this ID or this ID or this ID, and if we got to like I can't remember 1,028 was its max. So if you want on that side, you're toast.
So for the video people, the people recording Sager said he tried to do 1,000 ors against IDs or something, and it broke Solar eventually. Ask Sagers for more details. Okay, just to show a must, should, must not. I mean, this is nothing complicated. We're saying you've got to have Gandalf, you should have Frodo or Shadowfax, and you must not have Orlurian or whatever. That works as expected. He is Gandalf. Yes. And you can see you get, again, referencing back to our original documents, the Silmarillion references the term we don't want. Cooking like Gandalf doesn't say Frodo or Shadowfax. Gandalf defends Gondor, says Shadowfax. Lord of the Rings says Frodo. We look at the results. We can see Gandalf defends Gondor ranks high because it matched the must of Gandalf and it matched the should of Shadowfax. Lord of the Rings ranks high for the same reason, but it's matching Gandalf in the should. Cooking like Gandalf ranks the least because it matches the must. It doesn't match the should, and it doesn't have to. It just gets a lower score for not matching the should. And then the Silmarillion doesn't match at all because it had a rule that we violated. Let's just stop with one quick thing. We've got, let's say I changed my must should match. Let's say I didn't know how to type fancy characters on my keyboard, and so I typed it with a normal O. If I ran that search again, you can see this is matching now. Even though it's in my must not, to ElasticSearch, again, those characters are completely different. So if you're doing like a obituary product with Spanish people that have different characters than the English alphabet, you're going to need to handle those. One way that you can do it is by building your own analyzer. And so what I'm doing here in my mappings, we had an analysis when we did our normalizer before. This time I'm creating a custom analyzer, and I've called it the English ASCII Folding Analyzer. You have to specify what tokenizer you're using, and then you specify the filters that you're using. So I want it to work just like the English, so I have to get rid of possessive, I need to lowercase, I need to get rid of stop words, and I need to stem my word endings. But I've also added in an ASCII folding filter, which takes characters that look like other characters and folds them down into their normal characters. Because I had to remake this, I also had to define all my filters and tell them what language to use. So I created a stop filter using the English words, a stemmer using the English language, and a stemmer using the possessive English rule. So I had to recreate all those in order to make this filter. If I index with that, don't push up. What is that even called? Books, ASCII folding. Put all my books back in. And then do a search. No, I don't want that E. We're back to where we were, where even though I typed it with an O, if we look at that document now that's been analyzed, what ID is that? That is ID 4. If we look at the term vectors for that, and that's in summary, you can see that ASCII character has been collapsed and folded down into that lowercase o. And so when I search against it, it's going to run against that analyzer as well, and that O gets collapsed. That way you can treat those as easier characters for people to type. Okay? There's a lot more you can do with ElasticSearch. There's this relevant search book that talks all sorts about making good relevancy queries. I highly recommend reading this. It goes a lot more in depth and talks a lot about crazy situations. Very, very good book. The documentation's out there. Sometimes the documentation isn't super helpful. You might just have to play around with it and see how things work. You're welcome to use all these commands that I put together if that helps you do it. You can also just hit the rest endpoint or run it in Kibana, or we've got the ElasticSearch Slack room you can ask questions in. Spencer's in there, Matt's in there, I'm in there. Matt and Spencer probably have better answers than me, but we're all there. Okay, that's what we have time for. Guys, any questions before we end?
The shards, is that just for having large amounts of data?
Yeah, so when you've got thousands and thousands of documents, you don't want to just put that all in a single shard and bog that shard down. So you can have that distribute the documents across different shards. These have their own document frequency and term frequency, but when you've got lots of documents, it's probably going to be okay. And it will combine it all together for you. You don't have to search any different. You don't have to tell it to use shards when you're searching. It just figures it out.
Not a question, but I just want to stress one thing you mentioned.
Yeah.
And bring up one more small thing. The dynamic templating or dynamic mapping that you set to strict, I want to just second that with a lot of emphasis, because that's what bites Hive a lot, is we didn't have that, and sometimes we would insert something that was supposed to be an object, but it was empty, and so it ended up going in as an array, and that broke our what's called our river that synchronizes the data between MongoDB and ElasticSearch, and at that point we couldn't insert anything.
Yeah.
And that happens, and we just have to figure it out and fix it quickly because things go down. And so if you have a strict setting, that will never happen. And it just bet us enough times that just go strict.
Just go strict.
Yeah.
Yeah, that's my recommendation as well. Spencer, for the people on the video, said Hive didn't do a strict on their mapping, so they could dynamically add fields that they weren't expecting, and it broke their search index, and Hive people sent in support requests.
Yeah. And then the other thing is I've done a lot of work with writing a kind of a custom data synchronizer. There's Mongo, there's rivers, there's things like that if you need to synchronize data between two things like MySQL or Mongo and Elasticsearch. And there's a lot of interesting situations I ran into, so just if you run into something there, I'm happy to share my experiences.
So Spencer said he can help you write scripts to get data from one source into Elasticsearch. He's done lots of that. One thing to say there is reading this relevant search book is really convinced me that it's a terrible idea to go straight from the database into the index. There's a chance for you to do a document enrichment and to store things better for the index and to add additional information that will make searching easier. A lot of times what's stored in the database does not make a good search index, and you should enrich your document, transform it, change it, add helpful things to it for search, because search is totally different than storing, and you should probably transform things before they go in.
So let's say I have a string.
Okay.
And I have one or more words, a comma, one or more words, a comma, and one or more words.
Okay.
I want to boost the first set before comma 0,
Okay.
the second part 2, and
Okay.
the third part 4.
Okay.
Can I do that?
So you're probably going to have to do that yourself before you construct the search query that you're sending to Elasticsearch. So you would say in PHP, split by commas, take the first group, put it in my boost 4, take the second group, put it in my boost 3 or whatever, and then tell Elasticsearch to search that way. Does anyone have a different idea of how to do that? Okay. I would construct your search query correctly. There's a whole art of going from what the user typed in to what Elasticsearch is actually searching, what your queries look like. One of the search engines that we looked at was Algolia or something. I forget what it's called. It starts with an A. Yeah, Algolia. One of the neat things that they do is you can type in like Plumber Salt Lake City, and you can tell it, hey, look for what the user typed in, and if what they typed in is a facet, remove it from the search stream and add it as a facet. So if you type in Plumber Salt Lake City, instead of trying to do a match on Salt Lake City, it's going to say, hey, facet on the city category to Salt Lake. And instead of searching for the word Salt Lake, just give me the Salt Lake categories. And so some of that's happening before they even send it off to Elasticsearch. They're saying, search for a matching facet, find it, take it out of the query, put it in as a different search request. Sagers or Stephen?
I don't think you covered it very much on this one, but in terms of getting facet counts back.
Yeah, sorry, I did not cover that. Yes, you can get facet counts back. Google Elasticsearch facet counts, and there will be plenty of stuff to show you how to do that. I should have put that in here. Sorry for not doing that. I actually thought of that last night and forgot about it this morning. Other questions?
When you talk about enriching your data for search, so like with Mongo, you can tell the outlook or whatever, but would you probably just throw in some sort of queue instead?
Yeah. So like when new documents are added, put it in a search indexing queue, have your search worker pull things out, analyze it, run it through machine learning, have it go to Sam to document it up or something. Do whatever you want to do, and then put it in your indexer when you're done with it. So Sam's going to have to read all the classified ads and rate them 1 through 10, and then that will be a relevancy score. Okay, I'm going to stop the recording. Thanks, guys.